Now, as early as 1915, W.H. Bragg suggested the Fourier approach for analysing more complicated crystal structures. Now, I can do a demo here, and the Fourier method, we have as an analogy a single note. So a pure note, 440 cycles per second with time. Here is a portion of our crystal. It's the in projection the unit cell, and I've put on here a regular wave, a pure wave, but it's so many cycles per centimeter, let's say. So in the same way that putting pure frequencies together to make a tune, I can put frequencies together in space and reconstitute an image of a molecule. So here is another wave, and then a third wave. So that's a Fourier series involving 3 terms. So we need to carry on a bit to make our image, and the limitation of this demo is that the view graphs are a bit murky, so I'm going to add 3 terms at a time, and I'm going to pick low notes first. So here's the first 3 lowest notes, and I'm going to gradually add these in 3s, so that's 6 notes, 9, 12, and if I tell you that the compound is hexachlorobenzene, and the benzene is sitting in the plane of this, this is a low resolution image of hexachlorobenzene, and we can see the individual benzene molecules. This is the nicest one in the crystal, but they're at relatively low resolution. But this is the Fourier series approach to analysing quite complex crystal structures. And if I keep adding to my series here higher and higher frequencies, I begin to see detail, and we can now resolve the individual carbon atoms around the benzene ring. And this is just a summation of high spatial frequency with low spatial frequency notes.